Right, so in example 2, we are going to find our first type of normal probabilities. These are going to be cases where we are referring to them as less than probabilities. So we are looking for a probability of something being less than a specific value. Right, so using the normal model, N64, 3, suppose we were to select an adult woman from the United States at random and record her height. What is the probability of randomly selecting a woman less than 62 inches tall? All right, so remember, step 1 is to sketch our curve. So we're going to take our information about our normal model and label our normal curve that we have here. So our mean is 64, so that's the value that's going in the middle. And then our standard deviation is 3. Right, which means, again, thinking about our empirical rule, as we're going out to the right, we're going to keep adding our standard deviation. As we're going to the left, we're going to keep subtracting our standard deviation. So 64 plus 3 gives us 67. 67 plus 3 gives us 70. 70 plus 3 gives us 73. Right, so 1 standard deviation, 2 standard deviations, 3 standard deviations. Right, now we're going to label 3 standard deviations going in the other direction. Right, so now we're going to take 64 minus our standard deviation of 3. 64 minus 3 gives us 61. We subtract 3 again, we get 58. We subtract 3 again, we get 55. Right, so the first thing we want to do is we draw out a sketch of a normal curve, and then we label our means and our standard deviation. Right, now we need to draw in kind of what's relevant to the problem that we're looking at. So we are asked, what is the probability of randomly selecting a woman less than 62 inches tall? Right, so again, this is a less than problem. So I'm going to draw a vertical line in here right around where I think 62 would be. Right. So 62 would be right around there. Less than means we're going to shade our area to the left. All right, so we're just going to shade in this area in our curve. Okay. All right, so that is step 1. We have sketched our normal curve, we have put our value that we are looking for in there, and then we have shaded it appropriately. All right, now we're asked to find our z-score. Z equals x minus mu over sigma. X is our observed value. X is our value from our problem. Our value from our problem that we just put in our normal curve was 62. Minus mu is our mean, 64, divided by sigma, divided by 3. If you are plugging this into a calculator all in one step, remember it's absolutely essential that you put your parentheses on there. Or if you want to do it in 2 steps, that's fine. It depends on, for me, how I'm working them out. If we do 62 minus 64, we get negative 2 over 3. Right. And then we want to divide. Again, you can plug it in the calculator, do it all in 1 step, do it in 2 steps, whatever you're most comfortable with. When we're dealing with z-scores, thinking about our table has 2 decimal values in it. It has a tenths place and hundredths place, so all of our z-scores need to be rounded to the nearest 10th place. And it's absolutely essential that we round correctly. So this gives us negative 0.66666 repeating, but that rounds to negative 0.67. Right, so we have to watch our signs and we have to watch our rounding when we're calculating our z-scores. Right, determine the probability. Right, so here what we see is we see a portion of our table. This is kind of tiny, but this at least shows you in your notes where we're looking for this. Right, so what we see here is we're looking for a z-score of negative 0.67. So we're on the negative side of our table, and we're going to go all the way down to where we see negative 0.6, right, because that's the first number in our z-score, or the first 2 numbers really. The 0 out front, 0.6, that's our first decimal value. And then we're going to move over in our row until we have a 7 as our second decimal value. Right? So if 7 is our second decimal value, well, that means that we're going to stop right here at this value that we see here, 0.2514. So what that means is our area to the left of Z And I'm just going to notate this that we plug 62 in. You don't necessarily have to do this. So our area to the left of Z equals 0.2514. Right. Since we are finding our probability that is a less than, our area to the left is going to give us our less than probability. So our area to the left is going to give us our less than probability. So we're going to say that this is going to be close to 25%. So the probability of randomly selecting a woman less than 62 inches tall is about 25%. Notice that we use words like about or approximately because it's not exact. Remember, this is just a model, and we are doing some rounding and things in here. So we're almost always going to see, the probability is about, and then that's going to give us our answer. Right? So our area to the left is our probability in this case because we are looking for a less than probability.